So it's been a little while, and I have a new project, I think. So I have I used to fix these carnival boards all the time, and one of the problems I have is I don't actually have a full carnival setup, and I don't have carnival soundboards. And actually, these boards are used by multiple games. So it would be nice to be able to make sure that the sound is actually working. Now what happens is, if I can remember correctly, when it wants to play a sound or music, it will trigger pull down low, a bunch of one for each sound, one of the pins along here. Not obviously not every single one of them, but you know there's pins here. And there's actually not a lot to the circuitry to go wrong. I think if I remember correctly, besides things that are shared with the memory, there's only these two chips. But still, I like to be able to fully test things. So what I want to do is I want to make a ROM to replace that I just pop in there that will basically just trigger all the sounds and make sure the pathway is working, so that I can see with the scope that the different pins are going low. And then I might want to what I might want to do is then make a little like some type of LED plug-in board where I can actually see them without having a scope, and have a ROM and then just plug it in. I think that might be neat, and that might be useful for people if they want to download and download the code. But then we have another issue that I can, while I'm doing this, we might as well solve. Carnival uses 8 of these RAMs, and they go bad often. And the thing is, and this is like Missile Command too, it's actually hard to get a good test of the RAM and actually get valid output. Because a lot of the games, when they have a bad RAM, they will they have multiple RAMs, and what they'll do is they will write to the screen like a code that says, this RAM is bad. However, it's these RAMs that control the screen also. So that makes it a little bit of a difficult situation to test. Because it's going to be hard to write something useful to the screen if the screen is controlled by the RAMs that are bad. However, and Missile Command handles this. It tries to handle this by actually making noises out of the sound port, out of the pokies. But with Missile Command, the pokey often goes bad, or they have a little amp goes bad. Actually, the pokey often goes bad. So it's iffy. Like when you're testing a Missile Command board, I think often that when the RAM goes, you don't actually get a useful code. Same kind of thing with here. The Carnival actually I don't think has any test RAM or test functionality built in, but even if it did, it's got the problem of the thing that we would write to say that there's a problem is going to be part of the problem. However, because we have these, we could actually use that same concept if we had like a little LED display board where if I detect a problem with the RAM, I can make a test code. If I could test with the RAM rather than writing to the display, which is controlled by the RAM, maybe I just flip a LED light. I trigger a sound basically, which triggers a LED light, and then based on whatever LEDs are triggered, or whatever sounds play, maybe you even have rather than you don't even need the little board if you have a valid working soundboard. Whatever sounds play, that's what RAM you need to fix. So that's my idea, and so in this series of videos, we will be looking at the schematics to verify that this is the case, that when a sound plays, it gets triggered, figure out what the ports are, or which pins are which. We will write a test ROM using Z80 assembler. We'll use mame debug to test it, or mame to test it. And then we'll see if we can make a little hardware thing that actually lights up to verify that all the sounds are actually triggering. And then maybe we'll make a test ROM with that board or some type of thing like that to actually be able to easily test the RAMs without having one of these. So that's my idea. And we'll go ahead and get started looking at the schematics.
So here are the schematics to this logic board and the sound outputs. Here we have at the bottom of this box, we have the actual connectors to the soundboard, and we also have the flip-flops right above it in U64 and U63 that basically turn on the sounds. Now when the flip-flops change state to low, that pulls the pin on the sound hardware down, and that signals the sound hardware to actually play whatever noise it is. Now, how we know which sound to play is a combination of the data bus. One of the bits of the data bus will be set, as well as the address bus. The flip-flops are actually enabled based on the results of address bus 0 and 1, as well as whether a control pin on the CPU is being asserted. Basically, there's a special instruction in the Z80 called out. When you use the out instruction, you will send an address and a value. What this does is turn on the write line, the IO request line, and in these schematics, when those are both turned on, the IO write signal that is on the motherboard will be enabled. And if that is enabled at the same time address 1 or 0 is enabled, then the data can pass through the flip-flop basically and then trigger the sound hardware. So we can see when the output instruction is run, if the address provided has a 1 in address bit 0 spot, then U64 will be activated and the sound will be based on whatever data line is selected, whatever we choose here. So one of these bits will be set. D0 corresponds to output 2, D1 output 19, 2 output 5, 3, and so forth and so on. Now you can use the soundboard schematics to map the output pins to the actual pins on the connector to the soundboard, which are also in the Dual Vic schematic there, and then those pins to which sound actually gets triggered because it's labeled on the schematics. Or if you have a carnival, you can just look at the table that I've already made. But keep in mind that the sounds for each game on the Dual Vic is different because each has different sound hardware. Now you're thinking, great, I've learned a bunch of stuff here and I can figure out which sounds are where and how to trigger them, but how do I do this out instruction that is required? Well, that's where mame comes in. So in the next video, we'll start writing a test ROM to trigger all those output instructions to test the individual sounds, and we'll use mame to test that ROM. Hey, so if you liked that video, don't forget to hit the like button and consider becoming a Patreon patron to help me make more videos.